Good morning, students. Now HS1st year maths and yes, science streams maths. So we are doing and limit derivative almost all the regular exercises I have done. Now I am going to do the miscellaneous sum of this exercise. Yes, of course, miscellaneous is very much important for examination point of view. So let's start with this one. And yes, for that only. So limit derivative. Limit and derivatives that we are going to do. So yes, I generally prefer to speak in English on the basis that this should be what that when we think of calculus, first we have to think of this limit. After completion of full syllabus, I found so many students, if you ask them what is limit, then they are not able to say. So this is what misconcept, or they have studied not from wholeheartedly. Limit, generally limit means boundary. Here limit also somewhat things of that boundary ones. That boundary one we call, then of course we have to say what boundary? Boundary means the beyond that we cannot say. So, as boundary means, suppose x approaches towards a value 4. This means x is not 4, that x is going to near to the value 4. Either from the lower side or from the upside, it is this. So, for that, our fx, which maybe reaches to 12, maybe fx going towards the value 12. So that thing, that as x is going near to the 4, then fx, which depends on x, it has also a tendency of going towards the 12. Then this is named as limit of fx when x tends to 4 is 12. That is the meaning of this one limit. That is the thing. Here actually simply you can say as x tends to 4, then we have to say fx tends to 12. That is our limit. This limit exists if left hand limit is equal to right hand limit, left hand limit LHL, right hand limit RHL, left hand limit is short form LHL. We are habituated with LHS in class 10. Now LHL. Then RHL. We are habituated with RHS. Now RHL. That is right hand limit. This will exist if LHL is equal to RHL. So we can say if limit fx x tends to 4 minus 4 here power minus 2 is little less than 4. So it is LHL and RHL is what? Limit fx x tends to 4 plus. So if they are equal and if this value is 12, then also you can say this limit exists and its value is 12. So this is our limits. Just I have revised the previous one. Then I am going to explain again the derivative. Again and again I am telling because it is to pierce in your head that meaning of derivative should be like that. The meaning of derivative is what? It is the ratio. Remember, in physics what definition they are generally telling? That derivative means division of something. It is just for physics. One subject cannot be differently explained in different way. Different topics or different, say, this derivative, when we say in maths, it should not be different from physics. But physics, what they say, that is anything if we divide into so many parts, that is derivative. It is simply they are saying, but actual meaning I have to say, remember something difference between maths and physics, same thing. I have to say that if 1090 in maths, if I want to tell 90 degree, then in mathematics we will tell it is what? Undefined. That is, we don't know the value of 1090. That is, we cannot express. But in physics, same 1090, we are telling it is infinity. Infinity and undefined both are not same. But for the purpose we are doing, we have treated this one as infinity in physics. Infinity means a very, very big term. Very, very big term and undefined. They can be same, no. But for physics, that for every subject, every topic, we found that something approximation is taken. In undefined is possible when 1 divided by 0. But physics in practical it is found it is 0 where it may be not be 0. It is near about 0. If I keep so many 0 I am putting 1. This is 0 in some cases in practically we are taking. So for practically this is 0 means it is 1 by 0 that's why it is considered as this one, but it is still a very big term. That's why sometimes little may be different, but don't think that same thing is different from other. In different physics, one value, and in this maths, another value. All may not give the explanation, but my explanation on that is like that. Now, my definition in maths, derivative, it is a ratio. Remember, it is ratio. We cannot say that I divided the whole things in so many parts. Yes, practically it is happening. Actually, it is dividing. But theoretically, it is ratio. Ratio of what? Small change in dependent variable. If we take y as our dependent variable, then small change in dependent variable is delta y. If I think and small change in our independent variable, that is delta x, if I take, here it is increment, but it is here not increment. It may be increasing delta y, may be a positive term, may be a negative term, may be a 0 also. So increment in y, change in y, always you cannot say it is increment. It may increase, may decrease, may be constant. If we take this ratio and when we consider it is a very small term, that is when you write delta x is very small, that is approximately 0, then this ratio is called as derivative of y with respect to x, differentiation of y with respect to x. This is the general meaning. So what is the general meaning of derivative? Derivative is a ratio of change in dependent variable with respect to the very small change in independent variable. Derivative is a ratio of change in dependent variable by very small change in independent variable. So this is our derivative and this is our dy dx. Sometimes this can be written in short form. In another form, if we take delta x is 0, h tends to 0, fx plus h minus fx by h. This is the change in fx. This is change in h. So when we take this one, it is our derivative of y with respect to x. After that, then derivative will exist. Here limit exists if left hand limit is equal to right hand limit. Derivative will exist if LHD is equal to RHD. Left hand derivative means what? Limit h tends to 0, fx minus h minus fx by minus h is equal to limit h tends to 0, fx plus h minus fx by h. This is what when derivative will exist. See here, earlier LHS RHS, for limit LHL RHL, for derivative left hand limit is equal to right hand limit. After this, so yes, this is the thing of getting this one. Now after that we have learned so many forms of derivatives. So that derivative of x to the power n is what? N x to the power n minus 1. Then we have learned derivative of e to the power x is what? E to the power x. Then we have learned that derivative of log x is 1 by x. Then we have learned derivative of sin x is cos x. Then derivative of cos x is minus sin x. Tan x is sec square x. Cot x is minus cos x square x. Sec x is sec x tan x. Then cosec x is minus cot x cosec x. Then sin inverse x also I have written. Derivative of sin inverse x is 1 by root over 1 minus x square. Cos inverse x is minus 1 by root over 1 minus x square. Then tan inverse x differentiation is 1 by 1 plus x square. Cot inverse x is minus 1 by 1 plus x square. Then sec inverse x is 1 by x root over x square minus 1. Cosec inverse x is what? Minus 1 by x root over x square minus 1. So that much the things we have done. Derivative should be what? Good one. Otherwise we face problem in maths, physics, even chemistry also we may face problem. So let's start miscellaneous examples of this limit derivative. So miscellaneous exercise we are going to start. First one, they say find the derivative of the following functions by first principle. So here it is given minus x, let fx equal to minus x. So then if we want to differentiate this one f dash x, we have first principle f dash x is equal to limit h tends to 0 fx plus h minus fx by h. So limit h tends to 0, x plus h is minus x plus h minus x divided by h. If we draw this bracket, then it will be minus x plus h plus x by h. X cancel as h, this is 1. So limit h tends to 0 is 1. If we draw the limit, no place of putting the value of h as 0, so we will get 1. So this is our first derivative of this function fx. Then number 2, that is here fx is given as minus x to the power minus 1. This actually means 1 by minus x. So now if I want to do this one, then f dash x will be equal to limit h tends to 0 fx plus h minus fx divided by h, limit h tends to 0 1 by x plus h minus x by h, limit h tends to 0. Then if we do, then this will be plus x plus h, then x minus this one, and this one is x plus h. This will cancel. Then limit h tends to 0, h x plus h. So this cancel. If we draw this limit, we will put 0, it is 1 x plus 0. So it is 1 by x square. So this is the answer. You see that every step how we have done. Now we are going to do question number 3. Here fx equal to sin x plus 1. How to do this one? That f dash x is equal to limit h tends to 0 fx plus h minus fx by h. So it is limit h tends to 0 fx plus h. Here if we put x plus h, here we have to put put x plus h. This is the rule. X, 1, 1. What you will put, this x will replace that 1. So its value will be sin x plus h plus 1 and fx to minus sin x plus 1. Limit h tends to 0. This is sin c minus sin d. One formula is there. It is cos, twice cos x plus c plus d by 2 into sin c minus d divided by 2. So with that formula only we will write cos x plus h plus 1 plus x plus 1 divided by 2 into sin this minus that divided by 2, x plus h plus 1 minus x minus 1 by 2. So we can cancel x 1 1. So ultimately we get limit h tends to 0 twice cos x twice x 1 plus 1 2 plus h by 2. Then into sin h by 2 h. Now limit, I want to break this one. This 2 I can take below the h, then it will be h by 2. So now next step cos, if we divide, okay, twice x plus 2 plus h by 2. Here I want to write this one h tends to 0 sin h by 2. As I have taken this 2 below this one, so here also we will write h by 2. Students, I again want to repeat 2 if we take this in denominator it will go h by 2 form. Here also this one. Now see we have formula what? Formula is limit theta tends to 0, sin theta by theta is equal to 1. So here theta, both all should be same. So here h by 2 I am able to make, this one h by 2. Can we write this one as h by 2? H tends to 0 means it is very small. So h by 2 is also very small. So we can write this one. Now see if we replace h is 0, limit if we want to draw, then h if we put, then it will be cos x plus 1 only. So I have written cos x plus 1 only. And this one, according to that formula, is the 1. So sin x plus 1, if we differentiate using first principle, then its value will be like that. So I expect that I deserve right to give one homework, and that homework is 1-4. So definitely we will do and we will submit. Those who are not submitting, really it makes a disappointing thing to me that it is why not you are submitting, and your attendance also I cannot give as you don't submit. Now, question number 2. X plus a. They say find the derivative of the following function. It is understood that a, b, c, d, p, q, r and s are fixed non-zero constants and m and r integers. Actually they want to say except x and y you treat all the terms other than real number you take as constant. Of course these are arbitrary constant. It is obvious if they write also, if they don't write also, you have to think always like that. Now question number 2, x plus a. you have to differentiate this with respect to x. So it is so simple. dx, dx, dA, dx, x. You can think. Actually, formula you have to use the differentiation of x to the power n with respect to x is n x to the power n minus 1. That formula you have to use, or you can remember like dx divided by dx. It is the same thing. Divided by that thing is 1. This is 1, 0. So what we get? It is 1 answer only. Now question number 3. dds of px plus q r by x plus s. Here you can consider, you can do by multiplying and then getting the algebraic expression and get 2, or you can use u into v form. That also you can do. So here I want to use this one as u, this one as v. So u into v formula already used. It is what? R by x plus s you write and differentiate px plus q plus px plus q and differentiate r by x plus s. R by x plus s. Now, if we differentiate this one, p dx dx dq dx, then px plus q, then r ddx of 1 by x, then ds dx. Students, this is the rule only that constant should come out from the derivative. Derivative can go inside this one, and this line though by Leibniz product rule I have done. Okay, now I want to write the remaining r by x plus s dx by dx of 1, 0, px plus q. This will be what? 1 by x we can write as power minus 1. Then we have to write minus 1 x to the power minus 1 minus 1 plus 0. P r by x plus s px plus q. This will be minus r by x square. So this is our question number 3. Any doubt in any step? Now it is something I find also. It is maybe a lapse of online classes. Now I will explain. I am thinking you understood these things. Now at present you cannot read. So you have to read when you get this video. So I expect when you get this type of how you will answer. And it is all the things what I have explained earlier, with that only I have done. Now question number 4 I am going to do. ddx ax plus b and cx plus d whole square. Here again we have to use that is u into b form. Cx plus d whole square d dx of ax plus b cx plus d into d square into ax. Sorry, I have written wrong here because that should not repeat it again. You have differentiated that one. So next ax plus b we have to write d dx cx plus d whole square. So that way we can write cx plus d whole square square a dx by dx dv dx plus ax plus b. Here, if we break, then it is a plus b whole square formula, c square x square twice c dx plus d square. So Leibniz product rule we have broken, and now this one I have broken and now I have taken this one. Cx plus d dx by dx to 1, so a into 1, and this is 1, 0, plus ax plus b c square dx square dx twice cd dx dx plus d square dx. So what we get, a is here, a cx plus b whole square ax plus b. This is what? Differentiation of x square with respect to x. It is twice x. 2c square x dx by dx, it is to 1, and this one 0. So 0 1 that, right? So this is the answer. You may find that in book that answer given in some other way, so no problem. You can simplify and you can write this one. So after 4 we have finished. Sometimes I am getting some bindings for that. I am not able to do this all the sum in the exercise. But my maximum time practice is like that. Yes, trying to solve all the questions in an exercise. Now question number 5 I want to do, and probably this is my last sum of today's class. Ax plus b by cx plus b. So u by b form here I want to use. So how can you write b square? Then b differentiation of u, that is ax plus b, minus ax plus b differentiation of cx plus b. So student, this to u by b, that's differentiation, denominator 1 square, denominator into differentiation of numerator minus numerator differentiation of denominator. Cx plus b whole square, cx plus b, a dx dx, db dx, ax plus b, and here c dx dx, dd of this one. I have just broken this one. Now it is cx plus b whole square, cx plus b, dx by dx, it is 1, this is 0. Here ax plus b, this is dx by dx is 1, c, and this is 0. So this is our that answer. So little simplification also we can do. It is what? That if we break cax plus ad, cax minus bc by cx plus b whole square. This will cancel each other, and yes, numerator is ad minus bc and denominator is cx plus b whole square. So this is the presentation of this one. So students, only one homework I have given, and yes, you can do. And one thing I need to say, I will to do my best. Are you performing this one? Are you giving wholehearted effort? That is the you have to do. So with that expectation, that much for today.